welcome to, I think, the 9th lecture in the course. And as I said, here on campus we are at least coming near the end of the course, and if you look at the lecture plan, at least we are like here now, and we will be talking about the gang of 4 patterns, I think, for 2 lectures this week, and then we will do the object-oriented design principles on Friday. So we have like 3 lectures next week also, scheduled at least. So if we want to use them, we need to come up with some kind of topics for what to do. If you have any suggestions for lectures next week, it can be repetition of things you think is hard, could be other topics within object orientation. Please let me know. You can use Slack or you can send me an email. Also, some administrative stuff is we will have the individual exam, and you can suggest dates here. We took a quick look at it like this. So as it seems, Fridays are popular, so there is a great chance that we will do the first chance to pass the individual examination Friday, October 16. And I think I will also do some test running of the quiz system this week, so keep an eye on the course homepage. You will get some information there, so you can at least try it out. The questions won't be the same, of course, and there may be more questions on the quiz, the actual quiz, or less questions, and more time or less time. So, but you can at least get a feel for it and see that it works okay before doing the actual test. We will have some open opportunities for this week, but I will be posting it on the course homepage. We can make sure there are no problems before the first round. But if you have any opinions about the exam dates, fill in this form. And I also heard that some of the students had an exam this Friday. So chances are that we will do this on Thursday instead to even things out. However, I hope there won't be so many students that hasn't passed on the kind of like 2 occasions before that. So hopefully you will be ready and will not need to take the exam towards the end of the course. It will be multiple choice questions, limited time. You will have the chance to comment on questions that you have answered incorrectly, and I will take a look at your comments and could award you bonus points. But you will be test running the system this week, so keep an eye on the course homepage. Also, we have a deadline coming up for workshop number 2, the first submission, I think tomorrow at 12, and there is a link for handing it in. Looks like the last one also, and it will work exactly as this did during workshop number 1. So please fill in the form when you are ready. Supply a link to your portfolio or code or GitHub repository or whatnot, and I will be handing out the peer review stuff as soon as possible. Hopefully at after this, closely after this date and time, so that you can get a chance to test your fellow students' member registers as soon as possible, because we don't have that much time for the peer review. It's like 2 days, so we need to get started right away there. Otherwise, it will work as the first workshop did. Any questions on the workshop? Nothing. That is good, possibly. Anyway, to the topic of the day. We will talk about the Gang of Four design patterns. And if you remember, the Gang of Four was Gamma, Helm, Johnson, and Blisides, and they wrote a book sometime, I think, 94, maybe, possibly, something like that, called Design Patterns, Elements of Reusable Object-Oriented Software. And this was the first book, at least that I know of, that presented a number of design patterns and the idea of using patterns in software also. It was not a new idea because they got it from architecture, building architecture, where Christoph Alexander wrote a book on patterns in buildings. And they thought that this way of sharing common design is also applicable to software. This book is, well, it's a good read. You can probably find it somewhere. I think, yeah, it says 94 there maybe. But it's a good read. Get it if you want to read it. It has a number of patterns and a big example of using patterns also in it, and it's quite interesting. You also have the foreword by Grady Booch. I used the book from him when I learned object orientation at the university, and in his notation, classes were little clouds, not square boxes. So it was, and I also think that it was dashed. So the line was not filled on the cloud; it was dashed. So it was really messy to write it. Boxes are quite much better. But this was during the language wars. So we had a number of different notations, and this book does not use UML because it's too old. But it's a similar notation. So in this book we have 3 sections of patterns, starting with creational patterns. These are about how to create objects and not allowing, or at least encapsulating, direct instantiation. That is, should help you to create objects in different ways. We have talked about the creator pattern in the grasp context that guides us on who is to create objects. And we had a list of class A should create objects of type B if it contains objects of type B, and so on. In this, when the creator pattern doesn't help you or isn't that good, you can turn to these creational patterns. And the bold ones are stuff that we will at least touch on this course, more or less explicitly. We will be talking about abstract factory, and factory method. Singleton will be mentioned in the discussion about workshop number 2, so you can read upon of it there. I also think he has some discussion about Singleton in the book. We also have patterns for structure, how to structure objects, how to build more advanced hierarchies of objects in different ways. And we will be talking about the composite pattern and the facade pattern in this course. And we also have behavioral patterns where we get help to vary behavior depending on different factors. And we have talked about the observer pattern already. We did this in the architectural discussion of model view controller. And we will be talking about strategy, template method, and visitor. So we won't be talking explicitly about all the patterns in this book, and I also think that in the course literature all patterns are not present. But if you're interested, you can find out more online or buy the book. So let's go back to our little blackjack game. If you remember, the last thing we did was this rule variation. We created the American dealer and the Euro dealer, and we had an abstract base class here for dealer, and we could now implement this operation in different ways, depending on, okay, in America we start blackjack in one way, in Europe we start in another way, and we could imagine more ways to start a new blackjack round, maybe. So these two classes supplied a different implementation here. I think it was just the last card that was different in the American version that we did. This card is hidden. In the European, it's open. Not a big variation, maybe, but at least we can do more implementations and work out more fun ways to do this. So this was the last thing that we did. However, we could imagine that we would like to support many types of rule variations. We have already this start a new game, where we already have two variations. We could imagine rules for who wins the game. For example, should the dealer or the player win on equal score? In one variation, we could imagine that the player should win. In another, we could imagine that the dealer should win. And we could also easily imagine rules for varying when the dealer should take a card or not. In real blackjack, there is actually such a variation called soft 17. And that is that the dealer should take a card if he has a 17, if he also has an ace. Because if he gets a 10, the ace value will be reduced to 1, and he can continue to play. So we can imagine different kinds of rules here, and different kinds of requirements that we would like to vary. So the question now is, how should we incorporate this in our design? Any ideas? Well, we already learned that adding kind of like if statements and stuff like that, that's not so good. So that option is out. Even though it could be done, we could add some kind of state variables to the dealer that says, okay, if this is set, then you should use this rule. We used polymorphism for when we just had one rule. But as it turns out, this is not really a great idea when you have many rules, because we will get something like this quite fast. So to support these two variations for 3 rules, we need 8 classes for all combinations. So we need a European dealer, not soft 17 dealer advantage, for example, and so on and so forth. And this is not really a good idea, because when we have 2 rules and 2 variations, we will have 4 subclasses. And if we have 3 rules and 2 variations of each rule, we will have 8 classes. This is the example. If we come up with 3 variations for these 3 rules, we will have 27 classes to code. And if we have 3 rules with 4 variations, we will have 81 classes. So this kind of like explodes on us. And well, doing 81 subclasses to dealer, that's not really what we would like to do. So we need some other way of doing this. And here we have a new pattern called strategy. And the problem a strategy solves is how can we encapsulate an algorithm and make specific implementations interchangeable. And this is kind of like what we would like to do in the dealer. We have different algorithms for starting the game, for who should win the game, and when the dealer should take a card or not. And we would like to change these independently of each other. So what strategy suggests then is to encapsulate the algorithm in an interface. So we should create an interface for the algorithm. We should let different variations be realize this interface. So we should make classes that realize the interface. And we should let the client depend on the interface and be composed with specific implementations as needed. So we should add a member variable to the dealer that contains a reference to an object that implements the start new game interface. And we should use this when we start a new game instead of letting subclasses override this operation. And we could do this for every rule variation instead. From a structural point of view, it looks something like this. We have the client. The client is the class that we would like to protect, so to speak, from the variation of algorithm. And he uses the algorithm interface that has one or several operations for doing the stuff that it needs to do. And we have concrete algorithms that implement this interface. So we can vary what object the client actually uses, and the client is protected. And we can add more implementations here and not need to change the client at all, because the client just knows about the interface. So let's do this. And as usual, the problem is not understanding the pattern. The problem is, okay, what problem do I have in my code? What pattern is applicable to this problem, and how should my solution look based on this abstract solution? In our case, the client is the dealer class. That is the one that needs to vary its rules for different kinds of stuff. We need to devise an interface, and we probably have the algorithms already present in the American dealer and the European dealer. They should just be moved or and change name. So let's do this, and you can take a look at how it will be. For this, I actually will add a new namespace. Call it rules. And we will start by adding the interface. I will call it Start New Game Strategy. And this is a good convention to use to actually try to use the name of the pattern in the interface and class names, so that when you stumble upon this code, you can recognize the names, and then you know, okay, this is the strategy pattern, it works like this, so this is what I am to expect of the code. So the problem now is, of course, to devise this interface. And I think that we should take a look at the implementation that we have. So what we need in this interface is we need to have the player, and we also need to have the dealer, and we need to have the deck of cards so that we can take a card from the deck, give it to the dealer and player respectively. So let's just use this for now. And no implementation, of course. So something like this. And I think that we should move these in that one into that there and into there, and we will rename this also. Let's get that American. Should name. So, and they should not inherit from dealer. They should realize the interface instead. Go gadget copter. Yay! That's a first for this version at least. Let's recover. So why did it start the dice game? So let's hope we have no. Maybe we will need the lectures next week also. it seems like it kind of like did not like this at all, because the rules are not there anymore. All right. So let's just redo it. We could maybe just compile this and see what happens. Play. We don't get the scores here either. So this seems to be a really, really old version. So let's take a look at what we have in the seems like stuff got lost here, really. So I probably need to check this during the break to get a hold of things. So we will take, I think it's best if I do this now, so we will take 15 minutes of a break now, and I will get things sorted, I hope. So we can get started again at something like 9. So, well, let's hope this doesn't happen again. But anyway, 15 minutes of a break.